So I want to give a little lesson on dimensional analysis, and it's really just unit conversions. Let me take you back to where we were doing conversions with metric units. And so let's start our notes, and this is a lesson on dimensional analysis, and I want to see the examples in your notes. So example 1 was just what we have done in the past, and say you want to convert 300 meters into kilometers. Okay, how would you do that? Well, some of you know that the metric system is just simply a base 10, but if you forgot, you might need to, I don't know, you might need a conversion factor. So what I taught you guys is that you can convert using conversion factors to get the units that you want, as long as you know some equivalent. So you would need to know how many meters are in a kilometer. That's what I call an equivalent. So you should have committed to memory that there are 1,000 meters in 1 kilometer. And these are the numbers that you use to make a fraction to convert from one to the other. Now, which one goes on top and which one goes on bottom depends on what you want as the result. So if you want kilometers as the result, then kilometers goes on top and meters goes on the bottom. This is because you want the meters to cancel. So when you look at this, all you're really doing is dividing 300 by 1,000 to get your answer. And so 300 meters is 0.3 kilometers. Okay? Now, example number 2, again, you're writing these examples in your notebook. Example number 2 is sometimes you had to do some conversions, and this was on the last test, where it wasn't a base 10. It wasn't as simple as moving the decimal point. So say we had, let me see in this example here, say we had 6,336 feet, and we wanted to convert that to miles. We wanted to convert it to miles. Oh gosh, you would need a conversion factor to do that, right? And in order to get a conversion factor, you would need some sort of equivalent. So you would have to commit to memory, or you would be told somewhere along the line that there are 5,280 feet in a mile. So now you have what you need to put in your conversion factor. So you would write this as what you've got times some conversion factor is equal to the result you want in the units that you want. Now again, which one goes on top? Depends on what you want the result to be. In this case, we want miles on top and feet in the bottom. Okay? And if you did this multiplication, which is just really a division of 6,336 divided by 5,280, you would find out that there are 1.20 miles. That's the equivalent of 6,336 feet. One point I want to make is these conversion factors are very special in that the numerator does equal the denominator. And you might say, well, 1 is not 5,280. But it is if we're talking about miles and feet. So the special thing about conversion factors is that really, if you think about it, they're equal to 1, and so it doesn't matter if you multiply this times 1, you're always going to get the same result. It's just a matter of converting the units. I hope you understand that because it's an important concept. Example number 3. And this is really important, so you should pay attention to it, because in your project for your science skills project, you're going to be determining the density of clay, and then you're going to be looking up what you measured or what you determined as the density of your clay. You're going to be looking up that value on the internet for the known values of clay. And you're going to compare your measured value to known values in order so that you can determine the identity of your clay. So I want to take you through a step through converting units where it's not just one step. Let me give you an example. Say you measure the density of your clay, D-E-N-S-I-T-Y, You measured the mass of your clay, and you found it to be 16.54 grams, and you found that for that particular amount of clay, it took up 12.5 milliliters of volume. All right? So density is mass over volume, and if you did this calculation, you would get 1.32 grams per milliliter. Grams per milliliter. Okay? Now, then you went on the internet and you looked up some values, and you found a really great website that listed the density of all the clays, but it gave you the density in kilograms per meter cubed. Uh-oh. So, but what you're really asking, this is the same problem that we've had before. You've got 1.32 grams per milliliter, and what you're asking is, what is that equal to in terms of kilograms per meter cubed? Well, you would recognize this as a simple problem that you have to convert units, right? So you would need a conversion factor for that. It's 1.32 grams per milliliter is times some conversion factor will be equal to the answer that you want in the units that you want. But recognize here that you have to convert not only grams to kilograms, but you've got to convert milliliters to meters cubed. That's actually going to have to take two conversion factors. Okay, but no problem, because we have equivalents for both of those. In the one case, you know that there are 1,000 grams in 1 kilogram. And if you looked it up, you could ask Siri this, you would know that there are 1 million milliliters in 1 cubic meter. All right? So now, if I give you this information, do you think that you can calculate this? Why don't you pause the video and let me see if you can do this two-step conversion. Let's, first of all, choose which one you want to tackle. Let's go after, I don't know, the grams first. All right? We want kilograms on top. So 1 kilogram is equal to 1,000 grams. And then for this conversion factor, we want meters cubed on the bottom. I'd probably write that in scientific notation, but that might confuse you a little bit. 1 million milliliters is equal to 1 meters. If you did the math, you would find out that the answer is 1,320 kilograms per meter cubed. So if you looked up on the internet and you found a value for clay as 1,320 kilograms per meter cubed, my gosh, that would be identical to what your clay density would be. Hey.